Hello everyone. In this video I will talk about the concept of randomized algorithms. An algorithm that uses random numbers to decide what to do next anywhere in its logic is called a randomized algorithm. So we will be utilizing certain random numbers in the program or in the algorithm, and that random number will decide what to do next in the algorithm's logic. A true random number is impossible to generate using computer programs because there would be a definite logic to generate them. Thus, the random number produced by a computer is called a pseudo-random number. If a random number is generated by a computer program, then there will be a definite logic behind it. If the random number that we get is the output of that logic, then the number will be no longer a real random number. It is a fake random number or a pseudo-random number. And the standard method to generate a random number is given by the equation xi plus 1 equal to a into xi modulo m. This is one of the simplest ways by which we can generate a sequence of random numbers. So let me put some number over here. Let's assume that a is equal to 7, m is equal to 11. Then in this equation I need to give some value for xi to begin with. So as it is the first number, I am calling it as x0. Let's say I am taking x0 equal to 1. So this number that we are giving as the initial value into the algorithm is often called as the seed value. Okay. So to start the sequence of random numbers, some value of x0 must be given. This value is known as the seed. The first random number that will come out of this equation will be, so you can write x1 is equal to 7 into 1 modulo 11. So this is actually 7 mod 11. 7 mod 11 is 7. Then the next number x2 will be, we will take this number in the beginning, then it will be 7 into 7 modulo 11. So that will be 49 modulo 11. So a multiple of 11 below 49 will be 44. Then the remainder will be 5. So we have got the first number as 7, the second number as 5. So if you continue the process, you will get the number sequence as 7, 5, 2, 3, 10, etc. So this number appears to be a random number for us, but you can see that there is a definite equation which gives these numbers one by one. Now let's look at an example for the randomized algorithm where we will be using random numbers that will affect the result that we are producing. So here our aim is to shuffle an array of numbers. So imagine that I have an array of numbers over here. Let's say the numbers are 1, 2, 3, 4 and 5, and the indices will be 0, 1, 2, 3 and 4. Now my aim is to shuffle this array. So what I will do is I will store n is equal to the size of the array. So here the size of the array is 5. So the value of n will be 5. Then I need to generate the numbers I from n minus 1 to 1, which means that I will be taking the values of I from n minus 1 will be 4 to 1. Then in each of those steps I need to generate a random integer between 0 and I. Then I am taking that number to the variable j. Then I will swap the numbers at the position I and j. Okay. So in this particular example, n is equal to 5. I will be generating I from 4 to 1. So the first value of I will be 4. At that time I will generate a number for j, which will be a random number between 0 and I. So it will be essentially between 0 and 4. So I need to generate a random number between 0 and 4. So let's say the number I'm generating is 2. It's a random number, so I can have any number between 0 and 4. So what I have to do is I need to swap the numbers at the locations 4 and 2. So 5 will come here, 3 will go there. Okay. So this is a of 4 and this is a of 2. Okay. So you will have 3 over here and 5 over here. Now in the next iteration I will take a value 3. So I will be equal to 3. Now I need to generate a number from 0 and 3. So I need to generate a number from 0 and 3. So I need to generate a number from 0 and 3. So in between 0 and 3, let's say I'm taking a number 1. Then that value will be assigned to the variable j. So j will be having value 1. Now I need to swap the numbers at these two positions. So I'll be swapping the number at 3 as well as the number at the location 1. I will take 2 to this position and 4 will be taken back to the first location. I'm taking this away. I'm taking this away. So you will have 4 over here and 2 over here. Then in the next step I will have value I is equal to 2. Then I'm generating a number between 0 and 2. Let's say I'm generating the number 2. So I will be swapping the numbers at the location 2 with 2. So this number will not change because I'm swapping this number with itself. Then in the next iteration I will get a value 1. So that is the last value I can have for the value of I. Then the j will be between 0 and 1. So I will be generating 0. So you will have to shuffle the numbers at 1 and 0. So this 4 will be taken to the place of 0 and 1 would be taken to the place of 1. So I'm removing those two numbers and swapping it. So here I will have the number 4. Here I will have the number 1. So this is a shuffled array where we had initially the numbers 1, 2, 3, 4, 5. But this is a randomly shuffled order. This is one of the result of a randomized algorithm where we use random integers to shuffle a given array of numbers. Now let's look at one more example where we use the randomized algorithm. One of such examples is the Monte Carlo simulation problems. We will see an example by which we estimate the value of pi using the Monte Carlo simulation. Okay. The Monte Carlo simulations are the broad class of computational algorithms that rely on repeated random sampling to obtain numerical results. In some algorithms where we rely on computers in order to prove something, then we have to give some random values to those problems, and such problems can be called as the Monte Carlo simulation problem. We will see an example by which we will be estimating the value of pi using a simple Monte Carlo simulation. Okay. So in order to do that, I have drawn a figure over here where we have a square shape as well as a circle inscribed inside, and our aim is to estimate the value of pi. So in order to get that, we are taking the concept of the ratio of area between the circle and the square. So in this figure, imagine that the circle has a radius of r. So we can have the side of the square as 2r. And if you find the area of the circle to the area of the square, then the area of the circle is pi r square, and the area of the square will be 2r into 2r. Okay, that is pi r square over 4r square, and that is equal to pi by 4. Okay, now if you want to get the value of pi, then pi is equal to 4 times the area of the circle to the area of the square. Okay, so we know that the value of pi is an irrational number, so we'll have to go for a step-by-step approach where we will be estimating the value of pi to a certain number of decimal places. So what we are going to do in this particular algorithm is we will randomly take a x coordinate as well as y coordinate that will be creating a point over the plane. So you can have the limit of the diagram from -1 to 1 along the x direction, similarly -1 to 1 along the y direction, where the center of the circle will be 0, 0. So we will be sampling some points between -1 and 1 randomly. So we'll be sampling some random numbers between -1 and 1 in order to get the x coordinate as well as the y coordinate. So we will get a point over the plane, and we will find the distance of that point from the center. And if the distance is less than 1, where 1 is the radius of this circle in this particular example, because the distance from this point to this point is 1. And if the distance from this center to the point that we are considering is less than 1, then that will be a point inside the circle. That point will be counted into the area of the circle. And similarly, if any point is generated between -1 and 1 as its x coordinate as well as the y coordinate, that point can be counted as a point inside the square. So we can have that point amounting to the area of the square. The number of points that lies inside the circle to the total number of generated points. The number of points that lied inside the circle will be amounting to the area of the circle. Similarly, the total number of points that we are generated will be amounting to the area of the square. So this ratio can be written as pi r square divided by 4r square, which is equal to pi by 4. We can have pi is equal to 4 into number of points in the circle divided by total number of points generated. So the algorithm is this one. So initially we will initialize the circle points, the square points, and interval equal to 0. and we will randomly generate a x value as well as a y value. Then we will calculate the distance equal to square root of x square plus y square. If the distance is less than or equal to 1, then we will increment the circle points because that point is lying inside the circle. Similarly, we will increment the square point because any point that is generated between -1 and 1 will be inside the square point. Then we will increase the interval. If the interval is less than a certain number of iterations, we will repeat the step from this point, that is we will generate another point and we will continue. At the end, if the interval is less than number of iterations that we are intended to do, then we will stop the loop. Then we will be calculating the value of pi is equal to 4 into circle points divided by square points. So this will be giving us the value of pi with an accuracy up to certain number of decimal places. Then we will terminate the process. Okay, so here we are generating some random numbers in order to get the value of pi. So this algorithm make use of the random numbers. So this is an example for a randomized algorithm. I hope the idea is clear. Thank you.